Hi there. In this video, we're going to go through another hypothesis test example. So this is example 2 on smartphone training, and in these numbers I'm not including our Kiki Booba overview videos. This is our second full example, and let's go ahead and read it. So a company develops what it hopes will be better instructions for its customers to set up their smartphones. Okay, who reads instructions anyway? But the goal is to have 96% of customers succeed. Okay. The company tests the new system, and maybe this is like an app or something, I don't know. The company tests the new system on 400 people, of whom 376 were successful. Okay, so we've got 376 out of 400. Is this strong evidence that the new system fails to meet the company goal? Okay, so if we probably want to calculate this 376 out of 400 and see what it is. But I want to just write out what we've got. Our n is 400. Okay, and then thinking ahead to our first step, what's the parameter of interest and what's the direction of the test? Okay, so we're looking for, is it a mean or a proportion, right? Or two means or two proportions, which we haven't gotten to yet, but eventually they'll be all mixed up. So I'm seeing a proportion, right? Because I'm seeing a number out of a denominator. Okay, and then basically the variable is whether the customer succeeded in setting up their phone correctly or not, right? So that's a yes/no thing. Okay, so this is our parameter is P. Just like it was before, but this time, this one's different because here, now we actually have a goal. We have a null value that we're given, and we have an observed result. So it's important to distinguish between these two. Okay, so this, because it says goal, that's our null value. Okay, that's sort of the baseline that they're comparing against. And then when I look at what are we testing, is this strong evidence that the new system fails to meet the company goal? Okay, and then our observed result is our p hat. That's 376 out of 400. So I might also call this 96% p0, right, or p naught. That's our null value. Okay, so this just gives you another example of how to identify the null value. And let's go ahead and write out our hypotheses. So we're going to start with H naught colon P equals, and then we need to put in our null value. So that in that case is our 0.96. Okay, that the 96% of customers are successful. It's kind of that's their goal. That's what their sort of baseline assumption is going to be, that people are going to be successful. Okay, 96% will be successful. There's always that 4%, right? Okay, so then the alternate, you always want to look for the claim, or when it says test that, or test the claim that. In this case it says, is this strong evidence that? So here's our claim. The new system fails to meet the company goal. So now we need to think about what's the direction of the test. So fails to meet a goal would be less than that goal, right? So that would be a P less than 0.96. Okay, so this is a left tail test. Okay, so I wanted to show you a left tail. We did a right tail. I wanted to show you a left tail. Let's look at our next step. Using an appropriate randomization applet, so we've got to use one for proportions. Enter the observed statistic, simulate the randomization distribution for the sample size used in the study. Okay, so our sample size is n equals 400. Do you have a preference yet versus on Rossmann chance versus stat key? I'm going to go ahead and hit reset. I'm going to do, maybe I'll do both. I don't know. I think I just have Rossmann chance print out in the notes. So we're going to put in 0.96. This is our null. And 400 people. So we need to test different groups of 400. And this, it didn't erase my sample statistic from before. So I actually don't want to count those yet. Well, I'm going to go ahead and draw 2,000. Okay, there, it erased it for me. Okay, so I've got 2,000, assuming 96% of customers are successful, right? So assuming the null, then we're going to test our evidence and see, well, how likely is it if 96% are actually successful? How likely is it to get 376 out of 400? Okay, and I never divided that, so let me go back and do that. We also, so under here, enter the observed statistic. I need to write my p hat is 376 out of 400. Whoops, I still haven't found my calculator. I'll use my phone real quick. 376 out of 400 is 94%. Find that calculator before the next video. Okay, so then when I go back to the applet, this time we want to go to the left. So look at where 94 is on the scale. That's below. So this was below expected, right? 94% were successful. But what we want to know is, was that just due to random chance, the sample-to-sample variation? You know, one sample 97% figured it out, one sample 93%, one sample 99%. So we want to know this result of 94%, was that likely to happen under the null, or is it so rare that we're showing evidence for the alternate? Okay, so I'm going to pick the less than or equal because I have the left tail. And notice it does have the equal here, and that's because we're counting simulations that had that result or less. But when we write out the hypotheses, we don't put the equal in it because the equal is the null. But we do want to count if we got exactly 0.94. We do want to count if we got that result or less. So now you can see how it's red to the left, because this is a red, but a left tail test. And we have 0.0355. That's our p-value. So out of our 2,000 samples, only 71, or 3.5%, roughly 3.5%, got 94 or less people who figured out how to set up their smartphone with these new instructions. So we say that's rare. That's less than 5%. So that's pretty unlikely to happen under the null. Okay, so let me go back to the notes here and show you all the stuff that we had put in. So we put 96. That's our P0. And then this 0.94 is our p hat. There's a lot of p's. Are you noticing that? We have p0, p hat, and p value. These two p's are for proportion, right? Our null proportion and our sample proportion. This p is for probability. I know it doesn't help that much, but there's just a lot of p's. And these are all random samples of 400 with p equal 0.96. This is showing the sample-to-sample variation. So that's our randomization distribution. So it turns out it's fairly unlikely. Actually, when I did this before for the notes, I got even less, 0.0275. So I will write my new one on here as well, 0.0355. Okay, so that's something around the same level. Now, if one was under 0.05 and over 0.5, now that would be tricky, right? I have to decide, maybe do a few So that would be a little trickier situation. But luckily, both of these are less than 0.05. Okay, so we compare the p-value with the significance level alpha. Was there an alpha given in this question? Let's go back and check. I don't see a significance level anywhere. So we're going to assume that alpha is 0.05. Because it's not given. Okay, so our p-value, I'll use the one written and then, well, I'll use the green one because it's bigger. P-value equals 0.0355. Now I'm going to write that is less than 0.05, right? So small is significant. So this result is statistically significant. Okay, and that's part of our conclusion. And the next one, I'm going to take the A, B, C, D, E away. So it's kind of like we've got training wheels for right now, but eventually you'll be able to just write it all out. But of course you have the steps to refer to in the meantime. We're going to do so many though, you're going to get so good at it. State the conclusion in context, including the p-value, whether we reject the null or fail to reject the null hypothesis. Okay, so I'm going to start with a p-value again with a p-value of 0.0355. Result is statistically significant. Okay, next I like to talk about whether we reject the null or fail to reject the null. So if it is statistically significant, we're saying we reject the null. We reject the null hypothesis. There is evidence. And if you want, you can even put in the significance level. There is evidence at the 5% significance level that, and then that's where we put in our claim, right? So that the new system, so we could either say the new system fails to meet the company goal, and that's how they phrase the question, but I also want to get that 96% in there. So I want to say there's evidence at the 5% significance level that less than 96% of customers are or will be, presumably they're wanting to expand this to all their customers, right? Less than 96 of customers will be able to set up their smartphone with the instructions. Okay, so you can see there's a lot of different ways to write out the conclusion, but the main pieces are we want to say what the p-value is, we want to say whether it's significant or not, and that especially helps, at least that helps me when I'm going to write the next part of rejecting the null or failing to reject the null. And then that helps me say what the evidence shows, and then of course we got to put it in context. Okay, so let me just reiterate here, because this one was significant and the Kiki Booba one was significant, but the tire one was not. So what that's saying, because this is statistically significant, the result that we got was unlikely to happen under the null. And we assume the null is true. So if our evidence is really unlikely under the null, then we're going to reject the null. So that's why we reject the null, and we say that gives evidence for the alternate. Okay, great. Another one down, and I'll see you in the next video for our third example.